How's it going, everyone? My name is Hany Fahim. I am the founder and CEO of VM Farms, which is a DevOps as a service company. Thanks very much for attending my talk today, and thanks to the organizers for inviting me back. It's a privilege to be here, especially in such a beautiful venue. Today, I'm going to be continuing a series of talks called Tales from the Ops Side, and today's talk is called My Favorite Errors. And to kick things off, I'm going to start with a confession, which is I love errors. Sounds absolutely ridiculous, but honestly, I've come to realize that errors are just a part of the job. And in order to maintain my sanity, I must embrace the fact that things are just going to break. I've come to appreciate what various errors mean and where they can help you out. And when the pager goes off, most of the time my first question anyway is, what is the error? Knowing what the error messages mean can help greatly speed up an investigation because it usually pinpoints where to look first. To help illustrate this presentation, I'm going to use this diagram, this horrid diagram of a standardized stack. Now, obviously, components may vary depending on where you look. You may have external dependencies. You may have various levels of redundancy. But for the most part, this is a fairly standardized stack that we've observed. This could also be physical, cloud-based, container-based. Like most of my talks, it usually begins with the pager going off. Something is broken, and as a force of habit, my first reaction is, does it ping? I usually like to use the fully qualified domain name because it uses a DNS lookup as well. And the results of this may reveal problems higher up in the stack and avoid wasting a lot of valuable time. For example, one that I come across is non-existent or expired domains. So you have your system over here, I load it up and I try to ping a website, and it hits a DNS server and it comes back with an annex domain because somebody forgot to click that renew button, and your host says, cannot resolve host. I like this error because it tells you the problem right away. You can drop everything else and just go and fix your domain. May need a renewal, or maybe your authoritative DNS servers are down. This can also trick monitoring systems, however. It's happened to us before where a customer's domain expired and then the monitoring system hung on trying to resolve the host and just never sent out a page. This has since been resolved, however, and as a follow-up, we also added domain expiry monitoring and caught a few others red-handed. Another one, no route to host. So if you imagine this beautiful cloud over here is actually a bunch of interconnected nodes. This is the web that we talk about. And a route, when you try to ping, it takes a specific route to get to the endpoint. If for whatever reason one of the routes are broken and you do not have enough redundancy in that particular node, or all the redundant paths are down, your client is going to give you a no route to host error. This is kind of like GPS, where you have Google Maps or Waze, where you try to punch in an end address and it tells you, sorry, I don't know how to take you there. I like this because it tells you it's a routing problem right away. I usually use the traceroute tool to help pinpoint the problem, and usually if you call somebody about this, they're going to ask you for traceroutes. It could be a problem with your local ISP, your cloud provider, or hosting provider, or anywhere in between. You don't really have a choice anyway. You got to call upstream to figure out what's going on. This is a related error, time to live exceeded. If you've seen this before, back to this diagram of our path, if for whatever reason a couple of nodes along your path are broken and they start passing packets back and forth to each other in an endless loop. This is a network loop over here. Your system eventually is going to give up and throw a time to live exceeded error. Again, I like this because it tells you that your network provider is the likely culprit. It could be due to misconfiguration. It could be failed hardware. It could even be overloads. This has happened to us before where we had a redundant pair of firewalls. One got overloaded and couldn't send a keep alive packet to its daughter pair. So the other one took over, got overloaded, couldn't send keep alive, and they just kept going bouncing back and forth in an endless loop, and then caused this particular error. Again, local ISP, cloud provider, or somewhere in between could be the problem. And traceroute will help you out here, and here's an example of a broken traceroute. You'll notice hops basically 6 to 64 are bouncing between this .56 and 51 IP. This is a network loop over here, probably due to misconfiguration. Most systems stop after 64 hops because honestly, you don't need any more than 64 hops to get anywhere on the internet, and most of the time it's less than half that. And you can actually check what your local system settings by running this sysctl command and see what your laptop or client has configured. You got your connection reset by peer. I'm sure some of you have seen this before. Imagine you have an established connection. So you've done your TCP handshake with this particular endpoint, and for whatever reason, and you're starting to send data, and for whatever reason, the end system decides to send you a TCP reset packet, your client is immediately going to throw up and say, connection reset by peer. And in this case, the peer is the proxy. So this is the equivalent of somebody hanging up the phone on you mid-conversation. I like this error because it points me to the proxy as the likely culprit. Usually it's transient. I see this often when processes are being restarted, so connections are terminated, and you get a few of these errors, but then it recovers quickly. However, if it is persistent, it could indicate some sort of overload, so the process is maybe crashing in a continuous cycle, or it could be some other load management kicking in. Usually checking the kernel logs on the proxy, if you have the ability to, will reveal the source of the problem here. You got another one, connection refused. People have seen this as well, I'm sure. Imagining that you have a firewall, and you got like a little hole poked in it to allow traffic to go in. In this case, it's 443 for SSL. And then you got a process that is sitting there that is bound to that particular port, and you're allowed established connections to go back and forth. Imagining that that process crashes for whatever reason, so nothing is listening to that port anymore, but that firewall is still open. When you try to go and do your TCP handshake, you try to send a SYN packet, but you'll get a reset right back telling you that basically somebody's home, but they don't want to talk to you. You get a connection refused. So again, it's the equivalent of calling somebody, them actually picking up the phone, but then telling you to screw off. You know somebody is home in this case. I like it because the proxy is very likely the culprit. Could be due to a down or crash process like out of memory. So if the kernel assassinates the proxy process due to out of memory, basically go and check the proxy. It's going to tell you what's going on. Here's one that we all love, connection timed out. This is a TCP timeout. So imagining you want to talk to the proxy. You start off by sending a SYN packet. You get nothing back. So then after some time, you send another one, and then another and another. I think most systems send between 10 to 15 packets before eventually saying, I don't know what's going on. I'm not getting any response. And it gives up. So you get a connection timed out at this case. I don't like this error. I don't like this error at all because it doesn't tell you anything. You don't even know if somebody's home. The problem can be anywhere. It could indicate an overload, a misconfiguration of the firewall, the proxy, the app, the DB. It could be rate limiting. It could be local system problems. It could be network problems. You basically just hope that there is a better error message somewhere else to help you diagnose this particular problem. But under most circumstances, in our experience, I find that TCP errors are pretty easy to diagnose and are pretty easy to fix most of the time. However, because they're pretty low in the stack. However, most errors that we've encountered are HTTP errors. They are higher up in the stack. They are usually more complex to diagnose and to resolve. A while back, this guy named Steve Losh sent out this tweet that gives HTTP status ranges in a nutshell, and it couldn't encapsulate it more perfectly. You have your 100 series, hold on, 200, here you go, 300, go away, 400, you, the client, messed up, 500, I, the server, messed up. Very, very apt. If we talk about some 400, my favorite 400 series, you have your 400, which is you're trying to send a request, and the proxy, for whatever reason, throws a 400 bad request right back to you. I like this error because it pretty much tells you the client is the culprit over here. It probably sent an invalid request. Most of the time, usually it's an empty request, which is still invalid. Could be due to an interrupted connection. So somewhere between you and the proxy, someone cuts off a connection. The client may report a connection reset by peer, and then the server will record a 400. It can happen for the opposite case as well. So instead of sending nothing, you can send something way too big in your request cycle. For example, HA proxy has an 8 kilobyte limit, which is way more than you need to send any kind of request. But if you do hit that limit, you get a 400. Usually, I like to see if there's any client-side issues, errors to accompany the 400 to see what's going on. I'm going to skip over these quickly. Everyone knows your 401, which is basically you need credentials to get in, and your 403 to see, I see your credentials, but you're still not allowed in. 402, this is a fairly unused error code over there. It's called payment required. 402, payment required, not very well used, but I like it because it tells you got to pay your bills. Some providers like Google Developers API, they will use 402s to notify of request limits. And I know that Shopify uses 402s to announce to the world that you haven't paid your bills. Pretty blatant there. Everyone knows your 404s, right? You're not found. I like it because besides the obvious, if it is unexpected, it could be due to file permission errors, like the web server can't read certain assets on disk. If requests are all coming from bots, however, it could indicate broken links on your site, and we've seen this fairly often. Most bots are adaptive, and they'll actually back off if they see too many 404s, and in some cases stop crawling it entirely, which is not a good thing. If your logs are flooded with it, however, it could indicate some sort of brute force attack, somebody trying to find an exploit in your system. In fact, I've actually seen sites go down because of 404 pages. As an example, one particular client, in an effort to make their 404 pages more user-friendly, if an end user hit a broken link to some old product, they try to do a database lookup to give you a related product in case they can keep you on the site. But because that lookup, it hits the database, which is an expensive call, and 404s are pretty cheap to issue, it was really easy to topple an infrastructure with just a few 404s. You got your 405s, which is method not allowed. I like it because it's telling you that your client is trying to hit the wrong endpoint. I see this often with API endpoints where you're trying to strictly control what kind of HTTP verbs can communicate. If it is unexpected, however, it usually indicates a misconfiguration between your app and web server. As an example of this, we tried to set up CORS headers for one client, and we were passing back the HTTP options verb back to the app server. And the app server was not configured to know how to handle that, so it started throwing up 405 arrows. In this case, we actually just set up Nginx to deliver the options header directly back to the client and avoid hitting the app server. You have 408s. So imagine you establish a TCP connection with a proxy, so you've done your handshake, but then you neglect to actually send any kind of request. In a reasonable amount of time, you're going to get a 408 request timeout error. Under normal circumstances, this is not a big deal and nobody would see this. But in recent years, we've actually noticed a big uptick in 408s being generated on systems. And it's actually due to modern browsers having this thing called a predictor built into it. Chrome has one called a TCP pre-connect, where when you load up Chrome, it immediately establishes TCP connections with, I think, your top 6 websites in anticipation that you're actually going to hit it. But the problem here, obviously, is if you don't hit it in any reasonable amount of time, you're going to hit a timeout, and then you're going to get a 408 that's delivered back to the browser. And then when you eventually do navigate to that site, you're going to get that 408 immediately thrown in your face because content has already been delivered. I like this error, unlike other types of timeouts, which I hate. This one almost always indicates a client-side issue. As I mentioned, in recent years, there's that uptick due to various optimizations. To avoid that particular circumstance that I just talked about, usually you have to work around it and send empty responses for 408s. HA Proxy, for example, has this workaround where you configure your 408s to connect to dev null, which would just send an empty response. So when you time out, it just closes up the connection right away, and when Chrome tries to connect to it later, it'll just reestablish connection just like any other site. Not really a clever workaround, but it works. Then you have 499. So this is a non-standard Nginx-specific error. In this case, what happens is Nginx detects that its client, in which case the proxy, is hung up for whatever reason, and then it will log locally a 499 error. Usually it is not alone, though. Usually it is accompanied by an error on the other side, like a 504 gateway timeout. Usually it's coupled in this way. I don't really like this error because, one, it's Nginx specific. Two, usually the real problem is elsewhere. It could indicate, however, that the user pushed stop in their browser while it's mid-render. On the other hand, it could be a timeout on the proxy, like I just showed. Anytime somebody reports a 499 error, you got to keep looking for the actual error. It's not really helpful. You got your 500 series, like a 502. 502 is bad gateway. It's, for whatever reason, Nginx gave garbled responses or sent no response at all. Proxy is going to throw a 502 back to the end user. The same thing can actually happen between the app and Nginx. If Nginx detects that the app server threw up a bad response or an empty response, it'll generate a 502 and bubble up to the user through the proxy. Usually you'll see things in your logs like upstream prematurely closed connection, or connection refused, like another standard error, while connecting to the upstream. I like this error because it may indicate a problem with Nginx, which is unlikely. The more likely scenario is it's the application server. I've seen this often when applications crash hard and are unable to send a response for whatever reason, like out of memory, the kernel assassinating the process, or something unexpected. So the application just crashes without sending a response. Usually that would indicate some sort of exploit is actually being tested. I've seen this when application servers time out too, which is more likely. For example, Python-based applications, if you use gunicorn as your web server, it has its own internal timeout and will terminate any long-running requests. Basically, you just got to check the application or the kernel logs to figure out which is which. You have 503s, which are a little bit more sane. Imagining you put all your backend servers into maintenance mode because you're running a large database migration. In this case, any request that comes in is going to get a 503. I like it because it's manually triggered. It could be due to an overload. If you set up max connections on your proxy and you run out of slots, you could get this error as well. Most likely it is transient, though, especially if it's user-triggered. Hopefully they're going to bring the site back online someday. 504s. This is where Nginx, for whatever reason, takes too long to respond, and the proxy hits a timeout, and you get that 504 gateway timeout. And similar to the last one, it can happen as well between the app and Nginx. The funny thing about this error over here is that the app server can actually report a 200 OK. In this case, what's happening is that it just was too late to deliver the content, but it eventually did. But either Nginx or the proxy has already given up and sent a 504 to the end user. In fact, it's entirely possible that with a single request, that the proxy will record a 504 gateway timeout, Nginx will record a 499, and the app server records a 200 for a single request, which is incredibly confusing. A little trick that I learned to kind of avoid this circumstance is to set up your timeouts in ever-increasing values the higher up in the stack that you go. As an example, imagining you don't want any request to take longer than 30 seconds. What you do is you start by configuring the app server at 30 seconds, and let's say Nginx at 31 seconds, or whatever the next smallest increment is, and proxy will be 32. This way, if a timeout is hit, you know it's going to come from the origin, and everything is going to line up nicely. I don't like this error. I don't like it at all because it could be very, very confusing, especially when the app logs are clean. It could be due to the mismatched timeouts like I mentioned. And like most other timeouts that I also hate, the true issue may be hidden. You got to keep looking. So I talked about all of my favorites. My favorite all-time error are 500 errors. I love 500 errors. Why? Because they always come from the app server. And not only do they only come from the app server, there's probably some useful associated error in the logs, like too many connections. That is a database error. Go check your database server to figure out what's going on. It could be something standard, like connection refused. That, even though it's a standard error, because it's coming from a 500 log, you know that it's not anywhere else higher up in the stack, that it's probably an external resource that is having a problem. Same thing, connection timeout over here, it's still better because it's being generated from the app server. Even another type of 500 error is helpful, like 504 gateway timeout in a 500 because it's trying to connect to some external resource. I love this error because it always comes from the app, with an exception. It may occur higher up in the stack if you use some customized modules like Lua processing in Nginx or HA proxy. Because Lua is basically an application in of itself, it may produce a 500. But under most circumstances, if you don't do that, it's the app server. And because it's generated from the app, the errors are usually quite helpful. You get a nice stack trace as well, so it can help you debug it. It may be framework specific. Generic errors, like I mentioned, even coming from 500s are still more helpful. I have some honorable mentions of errors. You got could not obtain random bytes. This is a OpenSSH error, although other cryptographic apps may produce similar types of errors. Basically, you've run out of entropy, and you got to find a way to get more entropy. And it's ironic because computers actually do need some chaos to function properly. You got operation not permitted. This is a kernel level error that is probably due to some ACL, like you're trying to access a file or open a network port, but it's tightly controlled. This one, you got socket timeout after 10 seconds. This is a Nagios monitoring system specific error. Most people, when they see this, they see the word socket and freak out and think it's a network issue, but it's not. It's actually just telling you that some probe took longer than 10 seconds to come back. I don't know why they decided to put socket in there. You got your segmentation fault. This is a big one. You've hit some critical bug. Just go home after this. My all-time least favorite error, by far, is no error. No error. When you know something is wrong, but there is absolutely no error to tell you where the problem is, not even a timeout. I'll give you a story. One time, our client calls us telling us that their website has crashed and that it was down and wasn't loading, which is strange because there were no errors on our end. We hadn't received a page. The monitoring system was completely clear. Everything was green and nominal across the board. So at this point, I'm thinking, okay, maybe there's something wrong with the client's system. I try to test the site myself, and the site works, which is very strange. I checked the logs on the proxy, and the logs are clean too. There are no errors being reported. So it's definitely a problem with the client, right? They need to reboot their system. But after some back and forth with them, they were pretty adamant, no, this is a widespread issue. So there's some questions that spawn. Why is it working for some and not others? Is it some sort of routing problem? Called other team members and asked them, hey, can you test the site to see if it works? And it did. It did work for them. So almost certainly it sounds like a routing problem at this point. Some routes work and others don't. But then someone took a look at the server graphs and noticed this lovely pattern over here. Right around 7 p.m., traffic just basically dropped to 0, which was the first and practically only indication on the server side that there was really a problem. So more questions, right? Why is it working for some and not others? What is the key difference over here? One of the team members, they tried to pull up the site on their phone and noticed that it wasn't rendering on their phone at all. Okay, I was actually able to do the same thing. I pulled up the phone and nothing. It was just sitting there spinning endlessly, not loading any site, not throwing any errors. So I thought, okay, this really sounds like a routing problem because maybe my phone is going over the cell network and everything else is going over Wi-Fi, except for the fact that my phone was on the Wi-Fi network as well, which means that it's the same network, different clients, different results. What is the difference between here? It doesn't make any sense whatsoever. And then somebody remembered, hey, you know our laptops, all our company laptops, they auto-connect to our VPN when you load it, and you don't have a VPN on our phones. So what is actually happening over here is the routes for our client were being pushed over the VPN, and so it connects, goes over the internet, goes to the VPN, which is in the same data center as the client, and hits the proxy pretty much locally. The fact that the VPN was working rules out any routing problem because it would take the same path. So then what is it? Turning off the VPN and hitting the site directly, for the first time, we're able to replicate the problem on our laptops. It just sits there spinning, spinning, spinning. It took, I think I left my laptop on for about 10 minutes and nothing loaded up at all, which is incredibly strange. So where is my error? How do I even know how to diagnose this problem? Why is it just hanging? At this point, decided we needed to get lower in the stack to figure out what the problem is. I wanted to see what is happening when a system tries to connect. So busted open telnet and tried to telnet to the site and get this standard response, which is interesting for a few reasons. One, that IP is correct, so nobody is sabotaging it or hijacking it. It is the correct IP. The second is this line over here, connected to broken site. This tells me that someone is responding, that I did a TCP handshake with somebody, and it is waiting for me to send a request. Okay, so I issue a standard GET request to see what happens, and nothing. Nothing comes back at all. It just sits there, not even a timeout. This is exactly like the browser. So it begs the question, right? Is the request even making it over to the other side? I think it is, because I connected to someone and the IP is correct. So then on the proxy, decide to run this fancy TCP dump command, which is just a nice way of getting the entire request response cycle to be displayed. So under normal circumstances, you would see something like this. And this highlighted area over here is the entire request cycle. You see your GET request along with all the other headers over there. But when I tried it myself in this circumstance, you get absolutely nothing. Absolutely nothing came through. So who the heck am I talking to then? Where is my manual request? At the very least, I should be able to see the standard TCP packets like SYN, SYNAC, and ACK to tell me that I've established connection because I did a handshake with somebody. So who am I talking to at this point? So all right, at this, something's really fishy. Decided to call our upstream provider and ask them, hey guys, is there any weirdness going on? Do you see any problems on your end? They're like, nope, nothing is unusual at all. Oh, except for the maintenance that we're running right now, non-service impacting maintenance. Talk to me some more about this non-service impacting maintenance. Well, they're installing, apparently their upstream provider was installing some DDoS protection hardware on the network, which really does not sound like non-service impacting to me, right? But we were assured that it was non-service impacting because it's being configured in passive mode. So she just quietly passed packets back and forth. Of course, my OPSI sense is tingling at this point. Can we get some confirmation about this? Can we talk to them at least? What was happening over here is this last node that the upstream controlled, they installed a new device and updated the BGP routes to basically route traffic through this new device. And we were promised this thing is passive, so it should just quietly pass traffic back and forth. There should be no problem. And then you hear on the phone, oops. What's oops exactly? It turns out that passive mode was actually pretty active. Instead of configuring it into true passive mode, it was set to active, but with just really high thresholds. And guess what? Our client was crossing these thresholds, right? I had more questions, like what kind of DDoS device, when you connect to it and cross over thresholds, does it just sit there and hang indefinitely? I mean, I could do that myself. I don't need a DDoS device to do that. Well, we were told it needed to be configured. The device had not been finished tuned yet, so they wanted to actually observe what would happen. So they didn't configure rules on the router, so when it crossed the threshold, they just said, there's nothing to do except hold on to this connection endlessly. So why in a non-service impacting maintenance do you actually decide to make it active mode? Well, it was a last-minute decision by a network engineering team to do so, because we were told in passive mode it completely disables the device, including any logging of any activity going on. And because they still needed to tune the device, they wanted to observe what would happen with regular traffic passing through, which actually sounds completely reasonable, and it's something that I would do myself, except they didn't do their homework and figure out what the thresholds would be set to. Here's some lessons in follow-up. We didn't get any alerts at all in this whole time. It's because we actually, by design, disabled monitoring side timeouts, because we wanted to see what end users would see whenever monitoring would trip. But after this scenario over here, we decided to turn on monitoring side timeouts and just raise the thresholds really high, because honestly, at the end of the day, getting a late page is better than no page at all. Wanted to get notified for any and all maintenance events, and this was a bit of a fight with them. Their angle was they do a lot of non-service impacting maintenance all the time, and we would get dozens of these a day. We negotiated defining what major non-service impacting maintenance would look like, and in my opinion, installing new DDoS devices, updating BGP routes, that's a major change. So that's what we ended up with. Another lesson, no errors are no fun. You got to keep looking. Timeouts are absolutely necessary, but absolutely evil. If I were to rank them, I would say that no error is worse than timeout errors, which is worse than pretty much any other error. And that's all I got. Thank you.